Now we are starting this very easy chapter, progressions and series. Remember, this chapter is also like free marks, where the questions will be very easy, direct formula based without a lot of complications. You just have to solve a few numericals to get a hang of this topic. So the few formulas that are there in this chapter, very easy to remember, and a couple of problems here and there you'll be able to easily figure out what's going on. So let's move on to understanding what a sequence is first of all. So a function whose domain is n, where n is your natural numbers. So you have a function f of x, where your x can be any natural number, right? 1, 2, 3, so on. So such a function is called a sequence. A sequence is determined by its range, because the thing is, you have a function f1, you have a function f2, for instance, f3. All this f1, f2, f3, they are sequences. For all of them, the domain will be the same natural numbers, the set of natural numbers, right? So n will be for this, n will be the domain for this, n will be the domain for this. So how do you differentiate between f1, f2 and f3? Well, you differentiate that through their range, right? So the values that you get as the output in this sequence, that will differ, or that will determine what f1 is, what f2 is, and what f3 is. So a sequence is categorized or determined by its range. So usually a sequence is represented as basically a set of outputs. So this is a set, f1, f2, f3, so on, whatever the values in the sequence are. And if I call f1 as t1, so this f1, if I can say it's t1, f2 is t2. So likewise you have first term, second term, third term, likewise all the terms are going on. So this is basically a sequence of numbers. So what do you mean by real sequence? So a sequence whose range is a subset of R, which is real numbers. So all real numbers on your number line, any sequence whose range or whose output values is a subset of those real numbers. That means you can't have any complex numbers in your sequence. Such a sequence is called a real sequence. And coming to finite and infinite sequences, it's very simple. A finite sequence is a sequence which has finite number of terms. So something like a 1, 2, 5, 7 is a sequence which has 4 numbers. But something like infinite sequence is the one which has infinite number of terms. So something like set of natural numbers, 1, 2, 3, 4, just keeps on going, right? So there are infinite terms. So whenever you have infinite terms in your sequence, such a sequence is called infinite sequence, right? Coming to what a series is. So an expression that is obtained by adding or subtracting the terms of a sequence. So if your sequence has terms a1, a2, a3, so on up to an, then a series of those terms is basically the sum of those terms, or maybe the difference of those terms. So doing operations like addition and subtraction on the terms of a sequence gives rise to a series, right? So what we will be discussing in this next is basically this progression. So what is a progression? So a progression is that sequence which follows a pattern, right? So you had a sequence here, for instance, I wrote a finite sequence 1, 2, 5, 7. Now it's not necessary that this 1, 2, 5, 7 is following a pattern. It's not necessary for any sequence to follow a pattern. It can be just a random collection of numbers. But those sequences which do follow a pattern, they are called as progression, right? And our chapter is majorly based around progression. So we have 3-4 types of progression. One is your arithmetic progression, one is your geometric progression, which we will study next after arithmetic progression. Then we have harmonic progression, right? So there are lots of progressions that we have. We'll be studying some of them in this chapter. So this chapter is majorly based on progressions. So progressions are those sequences which follow a pattern. So we have this arithmetic progression which you have already seen in your 10th. What is an arithmetic progression? It is a sequence of those numbers, a sequence whose terms increase or decrease. They can either increase or they can decrease by a fixed number, right? So I have a sequence of numbers here, a plus d, a plus 2d. Likewise, I have, numbers are just going on. So this is your first term, this is your second term, third term. Likewise, if you keep going, this is your nth term. Now, your first term differs from second term by this d, by this common difference d. This d is called as the common difference. Why is it called common? Because it is the same difference when you move from T2 to T3. It is the same difference when you move from T3 to T4. And Tn minus 1 and Tn will also differ by the same thing. So whether I do T2 minus T1 or I do T3 minus T2, or I just do n minus Tn minus 1, I'll get the same d, right? So subtracting the term, that means the terms are differing by the same constant d. This d can be positive or negative, right? That's why the terms either increase or decrease by a fixed number. So if your D is positive, the terms will increase by a fixed number D. If your D is negative, the terms will decrease by a fixed number D. So what is the formula for the nth term? We have two very crucial formulas. In fact, these formulas are good enough for you to deal with almost all the problems as far as arithmetic progressions are concerned. One is your nth term. As you can see, your first term is this. Your second term is this. Your third term is a plus 2d. Fourth term will be a plus 3d. Right? So a and d are common. And if you have first term t1, then it is 0 into d because it's only a. If you have second term, if you have t2, then you have 1 into d, so you have 1 into d. If you have t3, then you have 2 into d. Likewise, if you have tn, if it's your nth term, it will be n minus 1 into d. That's why the formula is a plus n minus 1 into d. The next thing is the sum of n terms. This also you have seen in your 10th. The sum of n terms of an arithmetic progression is n by 2 into first term plus last term, or the nth term. Your first term is a, your nth term is, as from this formula, a plus n minus 1 into d. So this is a plus n minus 1 into d. So the formula for sum of n terms of an AP is n by 2 into 2a plus this. There was already an a there. 2a plus n minus 1 into d. Right. So as you can see from here, it's 2a plus n minus 1 into d. So a few very basic problems or very basic things, like what are the sum of the first n terms, right? 1, 2, 3, and first sum of the first n natural numbers. Now here the thing is, if you want the sum of the first n natural numbers, your n will remain as it is, n by 2. Your first term a here is 1, your second term a here, your first term a here is 2, your n is n minus 1, and your d is 1, because these terms are differing by 1. So sum of first n terms of a series, or sum of the first n natural numbers is given by this formula. This 1n plus minus 1 will get cancelled, right? And you'll have Sn is equals to n into n plus 1 by 2. So you can derive a lot of formulas. For example, you can also derive what is the sum of the first n odd numbers, right? What is the sum of the first n even numbers? You can derive a lot of things. So first n even numbers will be like 2, 4, 6 n terms. Like, so this will become your a. This will become your, so you can write your tn as a, which is 2, plus n minus 1 into d, which is 2, right? So this is your nth term. Your your first term is 2. So you can put that in this formula and get the formula for some of the first n even numbers. Likewise, you can get it for odd numbers also. So you can derive formulas and remember. So some of the formulas are a good exercise for you to remember as well. They'll help you save time during the exam. Let us discuss some important facts about an arithmetic progression. So few facts about your AP. That is, adding or subtracting a fixed number to an AP still keeps it an AP with the same common difference. That means if I had a number a plus a comma a plus d comma a plus 2d comma plus a plus n minus 1 into d, if I add or subtract every term with the same number k, if I add or subtract every term, even the last term, with the same number k, then this term, they're all differing by the same number, right? So this is a plus, for example, I'm adding with k. This is a plus k, this is a plus k plus d, this is a plus k plus 2d, right? So your common difference is still d, because when you subtract this and this, you will still get d, because the k will get cancelled in both cases. So the common difference remains the same, and also the AP still remains an AP, because they will still differ by the same common difference. Also, if I multiply or divide an AP with a common constant, right? So what I'm doing is I'm multiplying or dividing with a non-zero constant. So this is my a plus d, a plus 2d, so on, a plus n minus 1 into d. This is my AP. If I multiply or divide the terms of this AP with the same number, like every term with the same number k, so this whole thing with k, this whole thing with k, this last number also, the whole thing with k, right? If I multiply each and every term of this AP by a fixed constant, or if I divide it, but remember, when I divide it, I have to divide it with a non-zero constant, right? I have to divide it with a non-zero constant, because if I divide it with a 0, then it will become undefined, right? The terms will become undefined. So division with 0 is not allowed. So I can multiply or divide, but if I divide, I have to divide with non-zero. But whatever I have to do, I have to either multiply or divide with the same constant. then the AP still remains an AP, right? So it was an AP before, A plus D, A plus 2D. Even after multiplying with K, it will still remain an AP. That was the second important fact. The third fact is adding or subtracting two APs give another AP. So for instance, if I have x1, x2, x3, so on, xn, this is my first AP, and then I have y1 plus y2 plus y3, so on, yn as my second AP. Then if I add or subtract these, that means if I add or subtract these, x1 plus or minus y1, x2 plus or minus y2, x3 plus or minus y3, so on, xn plus or minus yn. This new sequence is also an AP. Just the way this was an AP, this was an AP, this new sequence, whether I add or subtract, is also an AP. So these were a few important facts about AP. Let's look at insertion of n arithmetic means between A and B. What do I mean by arithmetic means? So I had a number A, I had a number B. Between these two numbers, I inserted n numbers such that this new thing is my AP. So A to A1, the difference should be the same. A to A2, A1 to A2 difference should be the same. A2 to A3 difference should be the same. An minus 1 to An difference should be the same, and from An to B difference should be the same. That means this sequence should form an AP now. Your n numbers should be like that. So how do I do that? So basically, these are terms of an AP now, right? So this is your first term, second term, and likewise, this n will be your n plus first term, and B will be your n plus 2 term. So what is the formula for n plus 2 terms of an AP? The first term plus n plus 2 minus 1 into D, right? So your A is A here, your n plus 2 minus 1 is n plus 1 into D, and your n plus 2 term, what is it? It's B, right? So I have B equal to A plus n plus 2 minus 1 into D. So my D is this. So now I know the common difference, like how much should I move from A? Like how the value A1, how greater should it be when compared to A? The value A2, how much bigger should A2 be when compared to A1, right? How big should A3 be when compared to A2? So the difference between these two, I've got the common difference now. So my A1 is A plus D because it's the second term will be A plus D, third term will be A plus 2D, and likewise your n plus 1th term will be A plus ND. So the formula for A1 is this. I got D, I've just put D here. A plus 2D, I know the value of D from here, I'll put it here. I know the value of D from here, for getting A, and I'll put it here. So these are your n arithmetic means. Now, a very, very crucial property of the arithmetic means, and that is, you can get a direct question on this. What is the sum of the arithmetic means? So sum of the arithmetic means, so your arithmetic means also are forming an AP, right? So if I forget about the first term and the last term, these terms in the middle are also forming an AP. So there are n terms of an AP. So the formula of sum of these n terms, sum of your, A1 plus A2 plus so on up to An is n terms, n by 2, plus your first term which is A1 plus your second term which is last term which is An. So n by 2 into first term plus last term is the formula for n terms of an AP. So I know the first term which is A plus D, and I know the last term also which is A plus ND, right? So when you substitute the value of D here, you will get this particular formula, A1 plus n into n by 2 into A plus B. This particular thing will give you the value A plus B, right? And n by 2 is anyways outside. So sum of the n terms or sum of the n arithmetic means is equals to n into the arithmetic mean between A and B. So the actual arithmetic mean between A and B is A plus B by 2, right? So the term in between A and B is A plus B by 2. So n into that term is the sum of the n arithmetic means between A and B. This is the property, and it's very easy to derive this. Let's move on to geometric progressions now.